Okay, one final video on numerical methods. I just wanted to take the two videos previously and just put it into one big applied question. So in the exam, you may be given an applied question, which requires a numerical method to get solutions. So here's my one. An oven temperature as it heats up is modelled by the equation T, which equals 20 plus 20T minus 0.5 T squared minus 2 cos of pi T for T values between 0 and 20. T is measured in degrees Celsius. Little t is measured in minutes from when the oven is first turned on. Part A, show that the temperature is bigger than 220 when T is 19, but less than 220 when T is 18. Part B, use the rearrangement T equals 10 plus 0.025 T squared plus 0.1 cos of pi T and T0 equals 18.5 to find the time the temperature reaches 220 to the nearest second. And finally, part C, use the Newton-Raphson method to find the time tau, where tau is between 19 and 20, for which the temperature drops below 220 degrees Celsius. Use an initial approximation of 19.2 degrees Celsius and find tau to 6 decimal places. Okay, so it is exactly the same maths as we have been doing, it's just now applied in a situation. So I'm going to start with part A. Show that T is bigger than 220 when T is 19, but less than 220 when T is 18. Okay, so part A, best way to do this is to definitely use table mode. To get your calculator, go into table mode and plug in the function. So the function, leave at the top of the page here, is 20 plus 20x. Okay, calculator recognises the variable as x, minus 0.5 x squared, minus 2 times the cosine of pi times x. Okay, and we want to evaluate this function for t values 19 and 18. So I'm going to start at 18, I'm going to finish at 19, and I want to go in steps of 1. And let's have a look at the table. Okay, so when t is 18 degrees, when t is 18 minutes, we get that the temperature of the oven is 216 degrees Celsius, and when t is 19 minutes, we get the temperature is 221.5 degrees. So that is less than 220, as the question has required that we show, and that is greater than 220, again, as the question has required that we show, and that's it. Okay, that answers part A. We have shown that when that the temperature is bigger than 220 when T is 19, but less than 220 when T is 18. Perfect. Okay, part B. Use the rearrangement T equals 10 plus 0.025 T squared plus 0.1 cos of pi T, and T0 is 18.5. to find the time the temperature reaches 220 to the nearest second. So this is essentially saying that at some point between T is 18 and T is 19, capital T gets to 220, because this is a continuous function, and it's below 220 here and above 220 here. So it must be 220 at somewhere in between these two time values. The rearrangement is given in the question. You can assume that is true, but you could check that. If I set this equal to 220, and then it looks like making this t the subject, then this expression on the right-hand side should fall out. Okay, but you don't have to check it for this question. The iteration is T0 is 18.5, we're told to start there. And we have this definition for T, which we're going to use as our recurrence relation formula. So the next T value is going to be equal to 10 plus 0.025 times the previous T value squared plus 0.1 times the cosine of pi times the previous T value squared. Sorry, not squared, just the previous T value. So this is a recurrence relation, so the best way to deal with that on the calculator is to go into computation mode, put in 18.5 and push equal, so it stores it as the answer. And then we can use this definition here, where Tn is our answer, A and S button, to get the next value. So 10 plus 0.025 times answer squared plus 0.1 times the cosine of pi times my answer. And the question has asked us to find the temperature to the nearest second. Okay, so it's going to keep going until we get an accurate enough answer. So T1, the calculator says, is 18.5565. 5565. T2, just jot down a couple of these. 18.59078.072. And it's going to converge because of the way the question's worded. Slow convergence, but it's getting there. There we go, stops moving. It's 18.65047, blah, blah, blah. I don't overly care about that number. I just need to evaluate this number to the nearest second. So it's 18 minutes and something seconds. So I'm going to take this number and subtract 18 from it. So that's just the portion of the minute that I want. And then 60 seconds in a minute. So if I times that by 60, that'll give me how many seconds it is. I get 39 seconds. So it is 18 minutes. 18 minutes and 39 seconds. Okay, there we go. That answers part B. Okay, and finally part C. So part C says use the Newton-Raphson method to find the time tau, where tau is between 19 and 20, for which the temperature drops below 220. Use the initial approximation of 19.2 and find tau to 6 decimal places. Okay, so let's just take our definition of capital T, which I can see it and you can't, but it's 20 plus 20t minus 0.5 t squared minus 2 times the cosine of pi t. And we want that to equal 220. We're looking for the value of time, t, where this equals 220. And if I rearrange that, I will get 20t, subtract 200, subtract 0.5 t squared, subtract 2 times the cosine of pi t equals 0. So that then is going to be my definition of f. There's my f. This time of t, not of x. That's okay, we can deal with that. T is just the letter that we're using for the variable. Okay, so my formula then that I'm going to be using is x0 is 19.2, because we're told to use an initial approximation of 19.2, and the iteration formula, you're going to use this function in the Newton-Raphson definition, which is the next value, so that should be a t, that should also be a t. The next t value is equal to the previous t value, subtract the function of the previous t value, well that's f up there, so that's 20 tn minus 200 minus 0.5 tn squared minus 2 cos of pi tn, all divided by f primed of tn. So I'm going to differentiate this and plug t for tn. So that's going to be 20, that disappears, minus tn, and that's going to be plus 2 pi times sine of pi tn. Okay, so there's my iterative definition, and there's my first value. So what I'm going to do on here is I'm going to give 19.2, plug that in, so it's now stored as A and S on the page. And then it was the previous value, so answer, subtract 20 answer minus 200 minus 0.5 times the answer squared minus 2 times the cosine of pi times the answer, that's the function. And then the differential of the function is 20 minus the answer plus 2 pi times sine of pi times the answer. Okay, so the next iterative value, which is going to be T1, is 19.64865557, and it wants it to 6 decimal places, so make sure you're writing out the full calculator display in these figures here. Oops, 4656996. T3 is 19.47836677. T4 is 19.47836677. 832681. Okay, so that doesn't match up. Fifth decimal still different, so 85, 19.478326. In fact, that's the same. So to 6 decimal places then, I'm going to say tau is equal to 19.478327 to 6 decimal places, and we should check that before finishing. So if I calculate the function value at the bounds of this, so that's 19.478325, it's the lower bound, and f of 19.478325, that's the upper bound. Every number in between those two numbers rounds to that, to 6 decimal places. And again, table mode lends itself to this. So I'm going to plug in the function f. So the function, here we go, to find it here, underlined it in pink. So the function was 20x minus 200 minus 0.5x squared minus 2 times the cosine of pi x. And I want to set the values. Quite a small gap here. We're going to go from 19.478325 to 19. There we go. To 19.478325. And we're going to go steps to 0.1, 2, 3, 4, 5, 6. Okay. Again, I'm not interested in the numbers themselves, I'm interested in the change of sign, and we can see it's gone from positive to negative. So that confirms that there is indeed a root in that interval. So we're going to get 0.000002, and this one here we are going to have minus 0.000004. So change of sign, therefore tau is 19.478327. That's it. Okay. You should always do that check just to make sure that your final answer is correct, to get full credit. Okay, that's it. Thank you very much for watching. Hopefully numerical methods has been covered comprehensively, and check out my channel for other topics.